Okay, in this example, it says use the remainder theorem and synthetic division to find f of k. So, well, think about it. What is the remainder theorem? It says if the polynomial f of x is divided by some factor x minus k, the remainder is equal to f of k. Well, we already know what this f of k is. It just means take your f and plug in your -3. So there's a correlation here. All right, we can make the connection that whenever we plug in this number in here, it would be the equivalent of getting the remainder. So if I were to take this and divide it by, suppose, x plus 3, so take all of this divided by x plus 3, then this would give me the remainder. So let's think about this, all right? If I have this -3 here, I can perform synthetic division. All right, so let's go ahead and see what that would look like. So, and actually it's not -3. Now that I think about it, it is +3. Okay, so it's +3. Sorry about that. All right, so let's see. We've got 3. We're going to do a synthetic division, and nothing appears to be missing here. 4, 3, 2, 1, 0. So we're going to write the coefficients 3, 5, 3, -3, and 25. Again, this guy comes down. And we're only concerned with the remainder, so don't worry about any resulting polynomial here. So we're going to bring the 3 down. 3 times 3 is 9. And 5 plus 9 is 14. And 3 times the 14 is 42. And 3 plus 42 is 45. And 3 times 45, that's 135. And -3 plus 135 is 132. And 3 times 132 is 396. And 25 plus 396 happens to work out to be 421, the remainder. Well, there's the remainder from synthetic division. That's what we were concerned with. But guess what happens? When you plug in 3, okay, well, let's just do that really quickly. I'm not even going to bother to work this one out. You can verify this, by hand or on your calculator. All right. But I'm just going to show you what we're doing here. All right. So you plug in 3 into the original polynomial here, and you end up getting the fact that f of 3 equals 421. So we know in this case that this x, in this case, x minus 3, which gives you a k equal to 3, x minus 3, is not a factor of this polynomial, because if it was a factor, well, the remainder would be 0. But here's what the remainder theorem tells us, and this is the answer. So we verified it twice. We verified it with synthetic division, and we used the remainder theorem as well by plugging in f of k, and that's what we did there. So both match, and there's the remainder for this polynomial when it's divided by x minus 3.